Hello friends, so in this video I am going to talk more about the calculus, which I have already discussed in the part 1 and part 2 of calculus. So if you have not seen, please have a look on those videos as well before you move forward to this video. So I will begin with now begin with differentiation, and let's take an example. So this is the x-axis as usual, and this is y-axis. Now what I am going to do is I am going to see the derivative at this point. As usual, I told you that at any point you just create the tangent. So this is the tangent, and take the angle which is theta, and now take the slope. So slope is tan theta. As we know, suppose if this angle is 60 degree, suppose, so this is tan 60, and tan 60 is root 3, and this is positive. Okay, so here the differentiation dy by dx is positive. So what I want to convey is, if you go further at this point or this point, or you go this point or this point, any point, the slope is positive, and so the dy by dx is also positive. Now if you go to this point, you create the tangent and take the angle. Say this is, for an example, say this is 135 degree. Then you will write m is equal to tan of 135. This will be minus 1. So dy by dx at this point is negative. Okay, so in the left side the slope is negative, on the right side the slope is positive. In the middle, just at this, which is called the minimum, you can see both sides, this goes up and this also goes up. So y is increasing both ways, but at this point the y is the minimum. So at this minimum, if you create the tangent, so this is parallel to x, and angle is 0 at this point, so m is equal to tan of 0. So slope is 0 and dy by dx is 0 at this point. So at this point derivative is 0 at the minimum point. Okay, now let's take two examples. Let's take 2 points symmetric to this point. Just take a straight point like this at this point, and then create a tangent on this. So this, and the angle will be this one, and this angle is, say, here I am writing, this angle is 45, just symmetric. So 135 is 90 plus 45 on the other side. So it is symmetric. These 2 points are symmetric. Just to see the slope at this point, so where the angle is 45 for the tangent, dy by dx will be tan 45, and this is 1. So here it was minus 1, if you see, at 135, and here it is, just a moment, yeah, so tan 45 is 1 and tan 135 is minus 1. Now if you take 2 points here, if you see this point, if you see, just take 1 point on the right hand side like this one, and 1 point on the left hand side like this one, very close to the minimum. So we can judge that dy by dx on the left side will be negative, we have already seen, and dy by dx on the right side will be positive. And yet, since we are taking symmetric points, so since we are taking the symmetric points, this will be positive. Let's say this is plus say m, and let's say this is this one is negative of m, and say this one is plus of m. Now we know that the second derivative d2y by dx2 is the change in dy by dx with respect to x, right? This is saying that what is the change in the slope with respect to x, and the second derivative which we are calculating is at this point, this point. Okay, so if you see these 2 points, right side and the left side, this one is right and this one is left. So if you take the derivative, then this will become m right minus left. What is left? Derivative minus m. So this will be 2m. So this is positive. This is positive. So in the minimum case, the derivative is positive. The second derivative is positive, and the first derivative is 0 at the minimum case, at the minimum point. So this is all about which I wanted to discuss in this video. In the next video I will discuss more about this thing. So thanks for watching this video, and please also do not forget to comments and subscribe the channel. You can comment and ask the questions and any doubts if you have. Thank you.